Hello and welcome to D's ADD video. This is a conceptual video on limits, just a brief explanation on how you should think of limits when you're approaching your problems. So, if we look at a limit graphically, what happens is we're looking at this function here. This is the function y equals x plus 1. And if we were to approach a certain x value, in this case x equals 1, and if we were to zoom in on that x value from either side, would we approach the same y value? So in this case, if I had to zoom in, coming down on this function, right, if I'm zooming in to x equals 1, draw a little arrow there, it looks like I'm approaching the y value of 2, right? So what I did is I came in from the positive direction, values larger than 1, and it's denoted by using this notation here, x from the positive direction, that's why it's red, and our y value was 2. And then when we approach from the negative direction, we better get the same answer, otherwise the limit does not exist. Alright? So from the negative direction, we zoom again on the function, and what is that y value approaching? You guessed it. You can look at it, right? They're both coming into that point of 2. So from the negative direction, or value smaller than 1, we got 2. What does that mean? Well, that means that the limit as x approaches 1 from the negative, again, that's from the left side or smaller on the x-axis, right? Equaled the same thing if we approach from the opposite direction, larger values. We got a y value of 2, therefore the limit is 2. So that's graphically. Alright? Well, how about computationally? Well, computationally, what are we doing here? Well, we're literally picking values that are really close to that 1, that x equals 1 on that function, from either side. So let's do that with a calculator. Actually, you don't need a calculator because I picked a function that's easy enough to add 1 to. Oh, let's use a different color. I don't like yellow there. Let's use black. So if I use 0.9 and I get closer to the x value of 1, 9, 9, 9, 9, 9. Then if I add 1 to it, right, that's what you do when you have an x value to figure out what the y value is, and sure enough, we are getting really close to the value of 2, the y value of 2. That was from the negative direction. And that's what the graph showed us, if you remember, when we approached from the other direction. It's going to be values of 1.1. Let's start with just 1.1. 1.01 and 1.001. So when I add 1 to it, I get 2.1, and sure enough, what happens? It gets closer and closer to the y value of 2. So since they both approach 2 from either side, indeed the limit exists. And that's what we said earlier, right? So let's just backing it up. We're just trying to make sense of limits, right? So now we're going to look at it analytically. This is typically how you're going to see your problem and show up. Alright, we did computationally up here and graphically up top. So analytically, what happens? Well, analytically, if you get a numerical answer, it's nice and simple with limits. You literally just plug and chug, and you're done. right? So again, just plug and chug. I think I just got off the screen, recording screen, so let me rewrite the answer over here. And whenever I reduce, right, because 7 times 2 is 14, the 7's can cancel, leaving me 1/2. Alright, so that's basically limits. There are things to watch out for called indeterminate forms. Now basically an indeterminate form is when you get a 0 over 0, or an infinity over infinity. There are a few more of them we will discuss later, but right now, whenever you see these indeterminate forms, you will have to do algebra to change the appearance of your problem. And I will give some examples on the next video. It's just a concept, but basically in an indeterminate form it means that you just can't figure it out. They both go to 0 or they both go to infinity, but not at the same rate, so you can't cancel them, so you have to rewrite them, right? And undefined means that you have a number over 0 and it just blows up in your face. There's an asymptote usually there. But here, indeterminate, it might be an asymptote. It might be a 0 in the denominator with a number on top, or it might not. It might simplify to something easier. So, with that being said, that's the concept of limits. Again, quick recap. Zoom in from both sides. If you get the same answer, you're good to go. If you don't, then the limit does not exist. Larger than indicated with the plus sign, and smaller than with the minus sign, left and right direction. If you did a computational approach, it would be decimally close to the x value you're approaching from either side, and plugging in to get the y values, and you should get the same y value. And analytically, again, you plug and chug. If you get an answer, you're done. If you get one of these two things, you're going to do algebra until you get a finite answer, or an infinite answer, but not infinity or 0 or 0. So I hope this helped clear up what the concept of limits are. They're used in definition of derivatives and a few other techniques throughout calculus, so get to know them well. Alright?